Yo, what's up, and welcome back to another edition of our physics video lectures. So on this page, you're going to need to put a title, and our title for this episode is How to Draw Free Body Diagrams. So in the top, you need to, in this space, you're going to write kind of what a free body diagram is. In this little middle section, you're going to put the rules, and at the bottom, then I'll give you a task of something that you need to complete based on the experiment we did in class. Let's get started. So a free body diagram, if we think about a free body and a diagram shows information, and basically we're going to look at just one body or one object within a system, and we're going to draw a diagram of that one object, and so we call that a free body diagram. It's used to show the forces, the push and the pulls that are affecting an object. So when we draw a free body diagram, there's a few rules that we need to follow, and we'll use this flying hot air balloon as our example. So we'll say that this hot air balloon is going in the upward direction, and we'll put a person in there. So we'll say that this person, they have some weight, so they are also causing there to be a downward force, because not only is there weight of the balloon, but there's also the weight of the person that are pushing down, but the balloon is overall, it's going up in the upward direction. So let's draw a free body diagram to simplify this, because it's really hard to draw a picture of a hot air balloon time and time again, especially as we draw pictures or we try to represent different things in the world that might be too difficult to draw. We can really simplify them. So rule number one, the object represented is drawn with a box. So instead of drawing this complex hot air balloon, let's just simply draw a square that we're going to call a box. Now whenever you draw this box, let's put a circle in the middle so that it can help us with our further rules here. So we're going to draw arrows on this box, and the arrows are going to show the forces that are acting on the object. So like I said, we have the upward force of the lift of the balloon and a little bit of downward force of the guy that's in the balloon. So we need to draw our arrows to show the forces, but they always start from the center. So we've got our center mark already in our box. Now this is what it looks like when it's all set up, just a box with a dot in it, but then we're going to add arrows. And the size of the arrows represent the strength or the magnitude and the direction. So I'm not just going to draw arrows in any direction in any size, but since this balloon is going up, the up arrow needs to show that it's moving in the upward direction, and there's a lot of force pulling it up. There's a little bit of force pulling it down because of the weight of the balloon and the person in it. So you can see here that now I've got a simplified version of this hot air balloon. I've got the upward force and a little bit of downward force to represent a hot air balloon. Now if we look at a nickel that's on the table and we have a rubber band next to it, we need to draw a free body diagram for each of these. So again, we need to start by representing the system with a box. We'll do that for each of those. So you can see we've already simplified our system, and our system would be the coin and the rubber band. Now our free body diagram is only going to be of the coin. So let's draw the coin after it gets released from this situation. So it's going to have a little bit of a forward force as it slides across the table. But the table will provide a little bit of friction, so we need to add that as well. Alright, so here if we pull the rubber band back even further, then this nickel is going to be sliding across the table, and it's going to be going further than it did in diagram A. So in diagram B, we need to show there's more of a forward force, but we still have the same amount of friction because it's the same table, same coin. In diagram C, you can see we've pulled this rubber band back even further, and so the forward direction is going to be huge compared to the friction that will still be present. So you can see that now you can use these diagrams A, B, and C to show the different forces that are acting on that coin. And again, our arrows show the direction of the force, and they also show the magnitude or the strength of the force. Now, this is not showing the motion of the object. This is showing the force on the coin. So the force is applied by the rubber band. So we could say the rubber band force, and we could write that for each of those. The rubber band force is the forward direction, and then the backward direction would be friction. And so we have friction and the rubber band force. Those are the two forces acting on the coin. Now, for the last part of your science notebook page here, I'd like you to draw 3 free body diagrams, one for each of the trials in your paint blot experiment. I'll be checking those when you turn in your science notebook pages. See ya.